A ver, en el aula virtual. Es que no me deja editar, no sé por qué. Ah, now in English. Okay.
Very well. Bruno, are you ready?
Okay. Here in the aula virtual, well, I have to show the laboratory section, but now it's hidden because I have to do some updates and so on. But what I have done is in where you have the place for this, the lectures, the slides, we have a document that I will update another day because is what I explained you before that normally this was done at the laboratory, but this time is going to be online, so it's a little bit different, and I had to modify it a little bit. Okay. Well, here I think that you can see it. No, you have this document already available for you, I think. So we have to open this document, and we are going to follow it. Well, this is not the last version, because this one is a version I have modified quickly just in order to do it on the web. Okay. Well, the idea is that you go to a web page that here you have the link called Tinkercad. Can you open the document I told you?
Yes.
At least I can.
Well, if you don't say anything, I think that you are able to find it. So I go on. It's here.
Which is the document that you opened before?
Here in lectures,
okay.
Where we are in the first the first unit of the subject. Here I put it here. Okay. Well, then you have the document that we have to follow. I will show you a little bit how to work with it. The idea is that now you will work, all of you doing some of the exercises that we have here. And then the idea is that any of you can stop and ask questions, and then I will explain the things related to your questions. Okay. So the idea is that here we have just a small practice to introduce the microcontrollers. Is not the first lab. This is the 0 lab, for example. It's just to understand a little bit better what we saw in the slides about the languages, what is a microcontroller, and so on. Okay, it's about this. We are going to see this thing. The idea is that we should have been at the laboratory here at the university, and we should have played with it physically. Okay. Well, the idea is that we are going to work with this microcontroller. It's called Arduino, and I will show you now what is the things that we would have seen at the university, at the laboratory. At the laboratory, we have this element. Well, I have it here physically also. I don't know if you can see my screen, my camera. Yes, no, I think yes. Well, what I have in my hand here is this chip. This is the microcontroller, a single chip. But normally you find this chip that it's a microcontroller. It's called Atmega, whatever. Like if you said, I have an Intel E5 or I have an AMD or something like that, no, it's the same thing. But here you have a what we call development board. This development board has the microchip here, of course. Here has some pins to introduce some wires. Also here, it also has here a small chip. This small chip, I don't know if you can see it. This small chip is close to the USB. Okay, this is because this microchip has a kind of communication that is not exactly USB. It's another communication. So you need this chip, this one here, that it's very common in the development boards to translate the communications that the microcontroller is able to share with the communications in your computer with the USB normal wire. Okay. Well, you also have here a slot here to introduce the typical feed with the voltage sources typically known for other devices, no? Like, I don't know, I don't know now where you can find it, but it's very common. Well, here, the idea is that you can connect resistors, LEDs, motors, and so on. Okay, but we are not at the laboratory, so we have to use today a web page that is devoted to solve this problem that it's called, I haven't used it so much because I prefer the laboratory, but it's called Tinkercad. Okay, sorry. We go to this web, Tinkercad. Okay, and the idea is that you Tinkercad. Okay, Tinkercad. The idea is that you log in. I don't know if you have you entered here. Hello.
Okay.
Okay, please enter there www.tinkercad.com. You enter. You enter here, and then I don't know. Maybe I am logged in before because I wanted to see what happens, no? But the idea is that you can do here 3D designs for a printer, for a 3D printer. I don't know how to use it too much. You can.
I think we have to sign first in.
Yes, you can use the account of the university.
Okay.
Because it's to work here in the university with this. Okay, you can do here 3D designs that is really, it's normally related with the things with electronics and so on nowadays, but I am not going to work with that because I don't know how to, well, I don't know what to do because I don't know, we don't have to do anything of that kind here in our subject, no? You can think, well, you can cut things and rotate it and so on. You see, it's, well, that's the thing that you get when you click on the first thing that you can do, no, the 3D design. But it's not the thing we are going to do. The thing that we are going to do is this one, circuits. You go there, well, and you create a new circuit here. Are you here?
Not yet, because you have
No.
to register, so maybe it takes a little time.
Well,
Create new circuit.
yes, I will wait until all of you are here. Circuits, create new circuit. Okay, are you here now?
Yes, I mean,
Yes, I mean,
Yes.
Yes.
Can we go on, no? So we say here, create new circuit, okay? Well, here you can create circuits with basic components or all the available components. And you have here resistors, LED diodes, some switches, some trimmers, some capacitors or a sliding switch, a battery, another kind of batteries, another kind of batteries. You can use the board here that you know, no? I think from other subjects. Do you remember this?
Yeah, yes, sure.
yes.
yeah,
That you
In
have here.
instrumentation, we have worked with it.
Okay. And electronics with
Yeah.
us. You have this line all connected. You have this line all connected. You have this line connected and this line connected, but they are not connected between them. Okay. And like that all the time. Okay. Well, I don't know if we are going to use it or not. I delete it by the moment. But what we are going to do is here, Arduino. Okay. This thing is exactly the same. Well, maybe the mirror effect. It will seem that it's not the same, but I think it's the same. If you see,
No, it's the same.
It's the same.
okay, do you see? No, this drawing is the same as in my camera. No, more or less.
Yep.
yes.
Okay, so it's more or less the same thing. It's better going to the laboratory, but well, we have here the microcontroller and well, the idea is the following. When I switch on my microcontroller here at the university, I can open a programming environment. It's called Arduino, and when I open it, it detects. Well, I have here. If you see, I have one connected one with some lights, with a potentiometer and so on, no? You see? Well, so here, when I open this software, I say tools, and then it says puerto, COM9. That means that I have in this port, I have connected my board. Do you see it? Okay, so I can do a code that it works like this. Here I have the code between this case. I have the code that it's executed only once. Is the setup. You do it only once. And once the setup code has finished, then you will execute forever this code, because this is a loop. So I will execute the things that I write from here to here. And when I finish, I will do it again. And when I finish, I will do it again. And when I finish, okay. So the idea is that I can write some code here. For example, I can say that I have a pin. A pin is the place where you put a wire. I can say that I have, for example, a pin called 13, that is an output. Yep, output. Okay, this is a configuration. I could say it's an input, the opposite, but I'm going to say that this pin is an output. And then I will say something like, I want a digital change, a digital write in pin number 13 to be a high level. Okay. Then I'm going to say, I want to wait, for example, 1 second, 1000 milliseconds, in fact, is what I am writing. And then I say the same, but at the opposite. For example, I want this to be low for 1 second. Do you see? I have done a configuration to put this pin on output mode. That means that I can change the voltage outside my microcontroller. And those changes that I want to do are the following. I want to put my output at high level. I want to wait 1 second, and then I want to make that output at low level. Okay. The idea is that the microcontroller has on the 13 pin, it has a LED. So I will see it on my LED. Okay. Even if you don't connect anything, it's connected already on your board. Okay. So the idea, if we were at the laboratory, it would be to do this, then to say connect it to this port port, sorry, and then you will say verify or compile and download the code. I'm going to download the code, okay? Well, I'm going, and then it says, I am compiling. I am looking for errors. I am translating this code into matching code. And when it finishes, it will say, I am downloading the code. And now it says the code is downloaded. So now I am using my microcontroller. So let's see what happens. Let's see what happens. Do you see this slide?
Yes, yes.
1 second on, 1 second
low.
off. 1 second
And
on, 1 second.
how did you put the code in the Arduino?
With this
Like,
button.
where?
With this button.
But I mean, how do you connect Arduino to the
USB.
Okay.
Okay, so if you want, instead of 1 second, for example, a quarter of second, sorry. No, in order to do it more quickly, for example, no? If I do that, now you will see that now the blink is faster. Do you see it? Before
Yes,
it was slower. Okay, that's the idea. Okay, so what we are going to do now, for example, we could also say I have. I told you that I have a potentiometer in one pin called A0. So if I do, for example, I'm going to define a variable. Normally, the variables in Arduino, we define them globally. So I can say, for example, int potentiometer, for example. And then I can say here, potentiometer equal to the value, the value that I am reading from the analog input. And that idea, I say it like analog read channel name A0. That name is because of the card. Do you see here that it's called A0? Do you see?
Yeah.
So I have connected there a potentiometer. So the idea is that with this value now I can say, for example, this value goes. We will see it later, but this value goes from zero to, sorry, that is for comments, okay? From 0 to 1023. So if I say, for example, if potentiometer lower than 255, then digital write high, else digital write low. Do you see this? The idea is that I read the value of this input. If this value is low, I switch on the light. If this value is high, I switch off. Okay. So if I download now this code, you will see here now, depending on this potentiometer, the light should change. Let's see. Do you see?
Yeah.
Now it lights, now it doesn't light. Now it, okay. Well, these ideas, we can do it in our computer without the use of a microcontroller with this simulator. Well, the idea is that when you have a microcontroller like this, you can switch this button code, but normally at the beginning, it says the code with this thing. This thing is more for kids. It's like, this is called something like Scratch or something like that. Is that you move? Do you see? You move the code. Well, the idea is for engineers is that we don't use this, but if you want, you can, but it's not the idea. The idea is that we write code. Okay? Do you see this?
Yes, yeah.
Are you okay? Well, now that we have done this, let's see that we have here the same code that I did before. Do you remember? Pin mode, in order to say that this pin 13 is an output. Sorry. No, por favor, no. As you can see, I don't know how to use this fucking shit, ¿sabes?
I think delete, suprimir, or
Try the ESC button.
ESC.
I think this diode LED is very beautiful.
What? I don't know what is this. Okay.
I think better.
Press the- yeah.
Well, ¿qué es esto, tío? Well, we have here the same code as I said before. The setup. This code is done one time, and this code is executed several times. No. Well, the idea is that here you have the components, the code, but when you don't show the code, you see the components. If you can start simulation and you will see the same as I saw in my physically in my car. Do you remember? It was the same. And if you say here now, for example, you have to stop, of course, 250, and you say start, it will blink faster. Do you see it? No? Well, are you following the things that we are doing?
yes,
Yes.
no problem.
Yeah.
Okay. Well, now the idea is that I have a really simple explanation for you to work on this. That is the things that we have in this document. Okay. Here you have an explanation that I told you, but the idea is that a microcontroller has digital outputs, digital inputs, that they are configured here as output or input. Okay. But we have also as inputs. Well, we have here digital outputs that normally you have to put something outside that we will see. I'm not going to enter on that today, but for the digital inputs, sometimes you need, in order to use a switch, you need a resistor outside, because when this switch is opened, then you detect 5 volts. If not, if you don't put this, you don't know what you are detecting. That's what we call high impedance, no? Un cable al aire. So we have to put this resistor in order to detect 5 volts when we open. And when we close, we detect 0, no? Well, the idea is that some microcontrollers have this, what we call pull-up resistor. They have it inside. When the microcontrollers have that resistor inside, in order to use them, you have to write here input pull-up, okay? Well, then we also have analog inputs that I told you before how to use it, and analog outputs. The idea is that you will use the digital outputs as digital write, the digital inputs as digital read, the analog inputs as analog read, and the analog outputs as analog write. Okay? Well, the idea is that you have to define variables with the normally for the things that they are 0 or 1 Boolean, for the values without decimals int or long, for the values with decimal points float or double, and then you have to do the configuration routine, this one, and the continuous execution routine, that is this one. Well, some simple rules to follow for C language is that you have to finish with semicolon. You have some instructions that must go between this key and this other key. And in order to do things that must be conditionally executed or executed if the condition is not followed, you have these commands, okay? If condition, then tal cosa. Well, now the idea is that you follow this code. This is the thing that we have done all together until here, okay? And now the idea is that you follow these lines, okay, and well, and that you do the circuits that here are explained. For example, here you are called to put a diode here, okay. You must know, for instance, for these kinds of things, that you can go here, and then you have here the components are resistor. If that resistor goes to ground, so you can click here and then to ground. But if you want to do it more elegant, you can click in the middle and then it turns. Do you see? Okay. And for example, in order to put a diode, you must know that the plane, notice that this is round and this is plane, okay? La verdad es que plano no sé cómo se dice, pero, ¿cómo se dice plano? ¿Alguien lo sabe? How do you say plano?
Flat.
Flat. Okay. So the idea is that the diode has a flat part. Do you see it? It's like, okay, let's see here. Do you see it?
Yes, yes.
Well, you can see that in a lot of places because you have at home, I'm sure that you have these kind of components. Normally there is a plastic here, no? So you don't see this part, but if you have it, you will see this flat part, no? So the idea is that the flat part is, if you remember, is the cathode, okay? So that's the part that must go to ground, okay? So so here you must connect this one with this one. Yep. Okay, or like this, and then this one, for example, to the third, no? Okay, and then you have to do the code to execute the same in the third, for example, in the third pin. So you would do this in order to configure that pin. You would do this and this. Yep. And then you could say, you could do the same thing as before. Do you see? And if you want to do both pins, you would do this. Pin 3, pin 3, pin 13. You can do the opposite. For example, when this is high, this is low. The other one is low. The 13 is high. And then you will see they are doing the opposite, no? Well, maybe now it's too fast and you don't see a fucking shit, but you can do this. When this is on, this is off, and the opposite, okay? Well, the idea is that please, you should follow now this guide, okay? And you will see some examples to execute. You can copy the code and so on, and some exercises. The idea is that you do the exercises and you check if it works, okay? When you finish the exercises, please, here in the Meet, you should share your screen and show to everybody that it's working. And if you have a doubt, the idea is that you ask it, you share your screen, we all together see what can be maybe your error, and we check it all together. Okay. Well, here I have some comments like guarda el circuito. We don't care. Okay. It's this exercise is just to know how it works. We have something like 1 hour and a quarter, more or less. So the idea is that we can do this, that is really simple and short, and we can check all your doubts, and then we go on. So please, now I will be in silence, and please you do your exercises individually and talk when you need it, and share your screen and so on. Okay.
We have to do exercise 1, you said, or
Yeah. Well, the idea is that you exercise 1. Yes.
okay.
Yes. That's the idea. In exercise 1, the idea is that you connect 4 diodes in the pins that you are set. Well, so now that's the problem online, because this idea, when we are in the lab, you are working, you talk, no? But here I am looking at an empty screen of black color, so it's a little bit strange.
Yes.
And dynamic.
No, it's not the same like in the laboratory, so that's one of my doubts. If it would be a good idea to do this, or it's better that, I don't know, that I go on with the theory, or it's better that I am the one that is doing it and you duplicate it. I don't know.
It's okay. I think we can try to make it like this and see if it works.
Okay, so work, and please tell me your doubts. I am waiting here.
Okay.
For example, in order to connect 4 diodes, I recommend you to be a little bit to be careful with the electronic part. I mean, it's nice that you use a placa de pruebas, okay? Because you can share, for example, the negative. You can put the negative to ground, and then you can use several diodes and so on. Okay. Well.
Nacho, in the code, void setup is like for making it run.
What?
In the code, when
Yes.
the first line says void setup, this is for starting like all the program.
The void setup. Well, let's see. You have programmed in C in the last semester?
No.
No, no.
Oh,
Well, the idea is that the code that is inside void setup, you do it only once at the beginning. At the beginning, you execute the lines that are inside void setup. When you finish, when the microcontroller
like
finishes.
this is like to set the 13 pin like output pin.
Yes. Inside begin setup, you must say which pins are inputs or outputs.
All right. It's like to configure the Arduino.
Yes. The
Either
inputs
you
and the
program
outputs.
it with the loops and this.
Yeah, well, it's to configure the things that must be configured because there are other things that they don't need configuration. For example,
Okay.
the analog inputs, they are in a pin that it's only for analog inputs, so you don't have to configure it. The problem in Arduino is that if you see, well, I'm going to share another time the computer, my screen. If you see here, do you see my screen now?
Yes.
Well, these pins are only inputs, analog input. Do you see?
Yeah.
But these pins here, they can be input or output, and you have
All right.
0 and 1. You must be careful and don't use it because they are used for communication, transmit, received. But they are also the pins that are with this chip that I before told about it, that is used to communicate the Arduino with the USB. Do you remember I showed you
Yes,
before?
yes.
So these pins are the same as these LEDs and are the ones that go to this chip that goes to the computer. So you shouldn't use 0 and 1. Then
All right.
from 2 to 13, you have pins that can be or input or output. And furthermore, this can be a digital input or digital output. Digital input, digital output. Digital, okay? But the
Yes.
ones that have a virgililla, in Spanish, we say virgililla. In English, I don't know this symbol, okay? Lo de encima de la ñ, una virgililla, pero no, I don't know how to say it in English. I don't know. Well, the idea is that the pins that have this symbol here, they can be also used for pulse width modulation. Okay.
Yes.
This is the pins that you use with analog read. These pins, you use them with analog, with digital read or digital write. And these ones, you can use them with analog write. Okay. They call analog write to the pulse width modulation. We will see it later on the here on the memory. Instead of salidas analógicas, they are pulse width modulation. You know, no? I think these kind of signals from power electronics, no?
Yes.
Okay, so they say analog output, but in fact, analog write, but in fact, they are not analog outputs. They are PWM, okay? In the board, they say it correctly, PWM, but in the code, Arduino uses a false friend, no? Because they say, sorry, they say analog write, okay? It should be, I would prefer to be PWM write, for example, no? Because in fact it's a PWM, but okay, they use this. Well, I answered your question.
Yes. Now I start doing it.
Okay.
Nacho,
Okay. Yes.
did you say that we have to make a screenshot or something with the exercise?
We have to what? Sorry.
We have to save it in any place, or it's only
No,
to
it's
practice?
just, yeah, it's to practice, to ask questions, and if you want to show us, I did it work. The idea was this, and you can share your screen and say, if I push this button, it is doing this. That was the idea, for example, and I say, yes, it's okay, and you show to everybody or something like that.
Okay. It's because I've made the first.
Okay, if you want to share to see how it works or something like that.
Okay. Wait. Can you see it?
Yes.
Okay. And it only.
Okay, that was the idea. Yes.
Okay.
Okay.
Uy.
Thank you.
Nacho, how do it? I show you.
If you want to share, yes, if you want to share.
Can you see it?
Yes. Okay. Ah, you have changed the colors. How did you
In the here, if you pinch it, You can change the
If you
color.
click. Ah, okay.
Yeah,
Okay.
and I have changed the name.
Ah, okay. Okay, okay.
Can I show the secret I made?
Okay. Please.
Okay,
Show it.
let's
Show it.
see. Let's see. So this is what it was meant to be. Kind of.
Show the code, please. I didn't understand fucking shit, la verdad. No entendí una puta mierda de lo que has dicho, pero. What did you
Don't.
say?
Nothing really. Just change the time.
Sorry, but it's not your English, eh? It's the communication. It's something strange. It has some stops. Can you speak slower, please?
Yes. Now it's better.
No, I don't know your the other students, but I
No,
hear.
sometimes it is not really good. Sorry. A veces no se me entiende mucho.
No, but it's now it's better. It's maybe your microphone, eh? It's not the network.
Yeah, it is my microphone.
Ah, okay. Explain now, please, please.
No, nothing. Just here's the code and
Okay.
wait like half second and that's it.
Okay. Okay. Very well. Did you know Arduino before? Sorry. You have you used it with, I think, in electrical machines with the stepper motor, I think, no? Maybe with Ricardo, no? I think.
No.
No, I don't think so.
Is the first time you use it?
Yes.
Yes.
Okay, okay. Who was the one that didn't want to speak English? Bruno, no? You said before, I think.
What? Can you repeat? I don't understand.
Before the students said, Bruno, lánzate
No,
with the English.
my English is awful.
So is your time. Please share your screen and explain what are you doing.
I'm not finished.
Okay, okay.
I pretend introduce the potentiometer, and
But with
if I change the value, I want
value.
yeah, the value. I want to let it start and stop more fast. You know, but
Okay.
I don't think that I want to realize because I don't have more idea.
Well, try it. But you can follow in the instructions. You have some exercises to do that kind of things. Do you see? You are doing what you want, or you are following the instructions?
No, it's my idea, but
Okay,
I don't see the structure.
The idea is that maybe later in the instructions is an exercise like that, eh? But okay, what you want.
Okay. I don't see.
Can some of you show the first exercise?
But in the exercise, like you have to make it low and high, like if with delays or only like
No,
forever.
okay. The exercise doesn't.
Or-
The exercise doesn't say anything about the delays because in the instructions the delays are explained later.
It's just to put like the 5 and the 9 off and the other two, you know?
Yes, it's so easy like that.
So you don't need to make any video. You can make it with a picture, right?
No. This is not the first project. This
Ah, because
this
there are
is
ways to film the screen or something like this.
no. This is not the first project. This is the project number 0. It's something to motivate you on the understanding of what a microcontroller is. It's only that.
I think I have it right.
Do you want to share it?
Yes, if you want to, how can I share my screen?
I think that in the white bar that we have down on the link.
¿Presentar ahora?
Presentar ahora, correcto.
Okay. Okay. Does it work?
Yes.
Okay, so I have here my code and I make like this and the green
Hostia.
gets on.
Okay, you have a lot of wires. Be careful, eh?
Yes,
You
it's
should
like this.
you should use a proto board. It's better, no? I think because okay, it's a
This one?
yes. I think
I
because
made it with Arduino. So
but it doesn't matter because we are not going to do more connections, eh? But for other day, I think
yeah.
it's better that kind of
As I
elements.
made it before with the Arduino, I made it now with this, not with this one.
Okay,
So,
doesn't
okay.
matter. Go on. Okay.
I still making the next one or?
Yes, you all of you go on, never stop. The idea is that we should finish before the end.
I finished mine.
Do you want to share with us what did you did?
Sure. Do you see it?
Yes.
Okay. That's fine, no?
Yes. Well, the idea it was there is only one problem. It's working, but there is one problem that in a real application it would be a hard problem. Is that the pin mode should be applied to all the outputs that you are using.
Ah,
Pin mode 3 output, pin mode 5 output, okay?
okay. In the code, no?
In the void setup codes, yes.
Okay.
Well, I think that some of you hasn't shown the first exercise, no? I think Alejandro, I think he said anything, or Joaquin or Antoni, maybe?
Yeah, I have to show you the second one.
The second.
Yeah, sorry.
The second person.
Yeah.
It's true.
I'm going on with the next example.
Okay. And the other ones, I don't know if they are here with us or they are in another way place.
I've made the second. Can I show you?
Yes, show to us so we see how you are doing it.
Okay.
The second one is an exercise devoted to use
With an interrupter, or I don't know in English.
a switch. Yes.
Yes, true. Now it's in the position 0, and if I push it, it changes to 1.
Can you show the code?
Yeah.
Okay, you used input pull-up. Okay.
What happens if I only use input?
That you can't be sure that it can read a value of 1. You can only assure that you are going to read 0 values, but the 1 values, it's not, you don't know it. But in a real application here, I don't know, because this is a simulation. It doesn't
here
detect,
also
no?
doesn't detect it.
But okay, that idea is this one. Hey, when you say input pull up in a microcontroller, what you have is the following.
Do I close my screen?
Yes, if you want, I'm sharing mine. Do you see mine now? No, I think.
Yeah.
The idea is the following: when you have a microcontroller, and you have here a pin in which you want to read digital inputs, here you must connect this to 0 or to 5 volts. Well, normally what we do is to put a switch, to put a switch and until ground. And this element, the one that you have used now, no, the one that has a round bottom here or something like that, no?
See, a switch.
That kind of things, or the switch at your home, no, the one that you with the hand switch on and switch off. Well, the idea is that when you connect this, you effectively have these 0 volts, you have them here. But when you open, you here only have high impedance. You don't have anything. You have una antenita, a wire, nothing else. So in order to be sure that when you open this is 1, you must connect here a resistor. Okay. But the idea is that some microcontrollers, they have inside of their structure, this is plastic, but inside you have a really, really small circuitry. So there you can have sometimes, here you connect the 5 volts of la alimentación, no? The voltage. And internally you have there 5 volts, you have there internally a resistor. Okay. And here you have your pin. And what you can do is the following. You have here your connector, interrupter. And here you can say, please connect this internally. This internal connection is activated by input pull up. When you say the instruction input pull up, you are internally wiring this, cableando esto. Internally, you are wiring this piece.
Nacho,
that is the same as this. Do you understand?
Yeah. So if I only put an input, I don't write the pull up. Do I have to use a resistance as I made with the
A resistor,
LED?
yes. You
Okay.
could what you could do. The equivalent is doing only input, but putting outside the resistor. I don't see here this one. No. The idea in this one is that when you push, you connect this one with this one, no? Or this one with this one. Terminal 1 ahí ve. No, this one with this one. Okay, so you can connect this, for example, to this input, I don't know, and this to ground, okay? But then you would, joder, and, joder, siempre se me queda este colgando. Okay, but now you would have to use a resistor that goes from. Lleva esto, no sé si lo podremos ver. Joder. A resistor that goes from here, okay, from here to 5 volts. Do you see there? 5 volts.
Yeah.
So you should do something like. Okay, that would work. So in order to avoid this thing, you have to write the instruction input subrayado pull up. Okay. Subrayado is down score or something like that. I don't remember. Okay. I think that there is people that didn't say anything, no? Marcel has said, Joaquin has said, Miguel Redón has said, Bruno has said, no? Camilo has said. But Alejandro Iniesta, Antoni Marí y Alejandro Aragón, I don't remember.
I think I did the last one.
And Antoni Marí and Alejandro Aragón have said
No,
anything?
no. But I do with other computer because for me it's more. One moment.
I think the first sí, yes.
Okay. No, it's only that you didn't say anything, so I didn't know in which exercise you were working or something like that. So
Okay.
when you want, you can ask questions, show your screen.
Okay.
Nacho, in order to connect the 5-volt pin to the switch, how do we using the pull-up? I guess is it input pull-up? How do we connect in with the switch?
Well, I have problems with your microphone, but I think I have understood the question more or less. Well, the idea is that you need normally you can connect in several ways. You can also connect what we call a this is a pull up resistor, but you can also use a pull down resistor. Okay. In this case, the idea is that when you don't connect the interrupter, the connector, the switch, then what you read here is 0 volts. No, you don't have here any current. So these 0 volts, they are here. Okay. And when you connect here, you have a wire. So you have the 5 volts, you have them here. So you detect 1 instead of 0. Okay. So you need or a pull-up resistor or a pull-down resistor. Okay, but internally there are some microcontrollers, not all of them, that they have already for you a pull up resistor or pull down resistor. In this case, this microcontroller, the Arduino, it has a pull up resistor. If you want to use that pull up resistor, you must internally connect it. How do you connect it? With the instruction, pin mode, number of the pin, and input pull up. You have to write this thing in order to internally connect this, but you don't have to connect it physically because it's internal of the plastic. Do you understand? If you want to connect it outside, you must do or something like this or something like that, like this. Okay?
Okay, thank you.
Okay. Camilo, I think that you have some sound really strange. Okay, thank you.
Nacho, I'm going to show you the second exercise.
Okay, please do it.
You can see it.
But what was the idea of the?
If you are using the switch, these two LEDs are going to, if you have been touching it, this LED are on, and these other two are off. And if you in the other, and if in the other case they are in.
Okay, can you show the code, please?
Yeah.
It's nice, eh? It's working well.
Yeah, I
Okay.
have made a delay. If you are using the switch a long time, they will go on and off.
But be careful with that delay, no? Because the delay is in the middle of changing the outputs. Maybe it would have, if the idea is to wait until you take care of the switch, it's better to put it, for example, the delay that you have on the 14 line, the 14
Yes.
line, maybe it would be better to put it on the
Here?
between the 16 and the 17. Yes.
Mhm.
It
But
would have
if you
it would have more sense, no?
but
Because
if you put the delay in,
but what no, but the idea is that when interrupter it's equal to 0, then you should write digital write 3 high, digital write 5 high, digital write 6 low, digital write 9 low. I mean, you should say all the outputs which are the value, which is the value for each output.
okay, but yeah, I understand. But in this case, this will work because if you are not using it, they will not be on. Oh?
Yes, but well, it's some tricky behavior. It's the idea is not use tricks, trucos. I understand what you say, but that's not the idea.
Yeah, I understand. Okay.
If we use tricks, at the end, this subject will have will lose its significance. No, if anybody can do anything with truquitos, the idea is to be a little bit systematic with this subject. Okay. I understand what you did and it works, no? It's fine. But the idea is if we say when you switch on tal, es total. If you switch off tal, es total. Pues, well, the idea is to put that on instructions, because the idea of sequences, when I switch on this, then later if do that, the idea of doing that is using GraphThet. Do you understand?
Yeah.
Instead of using lines of code. Okay.
Okay.
But thank you for showing it.
Okay. Thanks.
Another one that should show, because I think
I finished the second one.
okay. Do you want to show it?
Sure.
Okay. That's nice.
Okay.
It's working nice, no?
Yes.
Okay.
Nacho,
Yes.
the second exercise is not working in my.
Can you show it?
I want to share it. Okay. This is this one is not is the example, not the exercise, but I had this connected like in the skin before, and I push it and it doesn't do anything. I have it like in parallel with the switch. So maybe something in the connections of the wires of something, I don't know.
Pin mode 3. The switch goes from the two interrupters. But what was the idea here? If when you switch on?
It's this one. I think if you switch on it, the LED goes on, maybe.
Yes.
But it doesn't work on mine. Because this is pulsing, right?
You are clicking, no?
Yes. And it doesn't make anything.
Maybe is when you use the proto board, you have to do click to make sure to. I don't know how you have to do click to be sure that is connected to that terminal. Do you understand?
I think they are all connected.
The one that goes from the third output. Try one thing. No. Try one thing. Right in the line 3. In line 3.
Yeah.
Okay. Copy that line and write it later there. The same with the pin number 13. Okay. Well,
I make it like.
No, don't do nothing because the LED number 13 it's inside of the board.
Yes, this one. Yes.
And later in line number 10, your line number 10.
I copy everything, maybe?
Yes, no, only number 10. Number 10? Número 10. Okay, copy it with 13. And the same with the line 14. Copy it, but with 14.
Yes.
With 13. Okay? Try now the switch. So the problem is the switch, I think.
Maybe. Have it connected like here, like in these two pins of here.
Yeah, no, that's nice. But the problem is the protoboard because okay. Let's see. Look that the upper values of the switch, the upper pins, are connected all the time because the please okay.
Yes.
The
And how can
do you
I
understand? You should
remove it from here?
or go down with the switch. Go down. Move down the switch.
It doesn't want to move. Okay. Maybe
No,
if
go up. No, not so much. Por ahí. No, tanto no, para abajo. Uno más para abajo, dos. Ahí, for example. The idea is that it doesn't touch the line red with the plus. La línea roja con el más que no, it was doing a short circuit. Do you understand?
Yes.
No, be careful. It's not connected. It's a fucking shit, no? I don't know how it works. I had problems also before.
Okay. Yeah, I think it's connected maybe.
Okay.
No.
I don't know what happens there, but something with the connections, no? I think.
One tricky thing about the switch, is that you need to hold the switch.
Okay.
I don't know what happens, but I think it's something with the protoboard because I don't know.
I'm going to try this.
See something like outside or something, no?
Maybe it's this one.
And you have to connect that one also. ¿No te deja? Ahora. Okay.
Sí. Maybe it's the resistance. Or... I think maybe this is not closing the circuit because everything is.
Yes, it's something strange. Maybe it's the resistor. Take out the protoboard. Delete the protoboard to see what happens.
It doesn't.
Oui?
Sorry, I think that I know what is the problem.
Please
Tell me, Bruno.
Tell me.
I think that if you put the interruptor in the pin with a I don't know what say the ñ, But you say
Virgililla in Spanish?
Virgililla does work because I'm try to this the interrupter in the pin 10
no, okay. I know what happened. You
because
said
this is analogic, no?
no.
Put it maybe
Input
this.
pull up. It's nice. And the idea is
Yes.
that it should be input pull up.
I copied like the same text here.
Yes.
Okay, I have the same problem and now I try this and it's work now.
Maybe
changing-
maybe the input number 2 doesn't have input pull up.
No, I made it with input 2 and it works well.
Okay.
And so where is the problem in your code? I don't understand. I don't see your problem, Miguel?
No. La he liado.
You must to play the I don't see.
La he liado. Put
Resume execution. You play resume execution.
Ahora lo he puesto así. One second. No. It's
No,
impossible.
but it's not. No. Let's see. It's not working when you look at hora del simulador. Do you see it?
Claro.
It's not working. It's something with the code. It's not executing the
But
code.
Miguel,
Go to code.
Yeah.
Go. And
Play.
and debug la pulga, el debugger. Maybe you have to switch off that because you are stopping your code all the time. La pulga, debug. That's for debugging, I think. So maybe it's not working because you are stopping the. Do you understand?
Yes.
Well, this is something historic. You will see when we do code these times, you will see a lot of times depurar el código. We say that a lot of times, but in English you say debug. Have you read sometimes that, no?
Yes, it sounds familiar.
Well, debug comes from this. Hemos encontrado un bug, ¿no? Have you heard that?
Yes.
Well, bug or bug, or I don't know the pronunciation, is pulga o bicho o ácaro, no sé, una mierda así. It's something small, okay? Well, the idea is that at the beginning of the computer science, the way they programmed it was to do the matching code, el código máquina, with ones and zeros in a card with some holes. Do you understand? If
Yes.
you do a hole, it's a 1 or a 0 or whatever. If you don't do a hole, it's a 1 or a 0 or whatever. So the problem was that sometimes the code didn't work because there is a bug, un bichito, in the hole, in the mechanical hole. Do you understand?
Yes.
That and they said, vamos a depurar. Let's look for bugs. Historically, it meant that they were looking for small bichitos that were inside of the hole of the card. Do you understand the idea?
Yes. So I stop sharing my screen because it's ready.
Nacho, I have a problem with the potentiometer circuit. Can I show you?
Yes, please.
I think the problem is with the code, but I don't see where is the mistake. I run it, and independing of which position is the potentiometer, only the red light turns on.
Okay. The value that comes from an analog input It's a value that goes in line 13, okay?
Yes.
In line 13, the variable pod must store a value that goes from 0 to 1023.
Okay, I have to
So
put.
in the first line, you have to declare the pod value as an integer, int pod.
Vale, okay. Wait. Okay, now it runs perfect. It was that.
Okay.
Thank you.
Nacho, sorry. Can I show the exercise too?
Yes, show, please.
Yeah. Tarea completa. No. You see that? Can you see?
You are not sharing anything.
What? No. Oh yeah, no.
Yes.
This is the code.
Be careful because you have also el bicho activado. Debug. Do you see?
Yeah.
El bicho azul.
¿Dónde? Where? Ah, yeah.
Be careful because before we discovered that was stopping the code.
But it's working.
No, you have the switch not connected to anything. Do you see?
Yeah. Oh, se lo he borrado. Wait. No, it's okay, no? If I press the button,
But is it stop? You are running now?
Yeah.
I can see stop simulation. I don't know why.
no, but no.
It happens something strange because
If I start simulation, that
now it runs. Okay.
it's okay, no?
No, but let's see. It happens something strange. Look at your time. And do you see?
Yeah.
And that line that is orange, okay?
Yeah.
Do you see that you have an orange line?
Yeah, but I don't know what is that. But it work.
It works or not?
Yeah, work. Look at this. I press the button and change the LEDs.
But they are doing something strange, no? They are like
Yeah, the orange line.
they are something like blinking, no?
Yeah, it's all the time.
And you have that line, that orange line. I don't know why.
No, I don't know.
Do a stop simulation. Do a stop simulation, and click on the first button, the one that is with an arrow downstairs. El que tiene una flecha para abajo.
Yeah.
What does it say?
Download code, and
Okay.
I open.
That's if you no is okay. Do nothing. Nothing. That would be if we would have a connected Arduino. Do you know? So
Yeah.
let's click on the debug. Let's see what happens. Add breakpoints by clicking on line numbers. Start simulation. Hover. Okay.
No, I don't know what is that line, but it's work.
Okay.
If I delete, try.
Okay, the key, no? Okay. But
Yeah.
be careful with the debugging, with the debug, with the blue color. Okay, be careful.
But when I
Something
press
is
the button,
strange
it's
because
a surprise.
simulator time 7. It's like stopping. I don't know why. It's strange.
It's more lento. I don't know.
Slow, primo.
Slowly, no?
Maybe, do something because maybe it's a problem of the simulator. Stop simulation and in line 14 before interrupter, do enter to write, do enter, press enter, and in 14, write delay 100. No,
No.
parenthesis 100, paréntesis, no, 100.
No.
100, suficiente. Okay, try that. Because maybe it's only a problem that it's an infinite loop is going crazy or something like that.
Oh,
You want to have the second exercise ready.
Yes, the time is better now.
Okay, maybe it was that only that it can simulate well, no?
Yeah, okay, thanks.
Nacho, you need to see the second one, or can I go for the third one?
No, you can go to the next one if you want.
Okay.
But I think that there is someone that hasn't still showed anything. No? I'm sorry because I haven't see your face enough, so I don't know who are each of you. No, it's normal.
Sorry, I didn't show the second one because it was taking a little bit long, and I move on to the third one.
It doesn't matter. Go on. Of course, yes.
I don't show anything because
It's working. It's working. Okay.
Working. If you want, I can show.
No, it doesn't matter. It was only to know if you were here or not, or okay.
Sobrado, Tony, díselo.
In English, please, Miguel.
Sobrado es show off.
Sobradation.
Ser un sobrado, no. To be a show off es ser un notas, creo, ¿no?
Pues también, Miguel, también.
Bien.
Ser un sobrado, no sé cómo se dice. I'm going to look for it. We will use that kind of vocabulary. That's the idea. Eh?
Street English is better.
Marcelo, y ahora show off.
A leftover. To be a leftover es ser un sobrado.
I have a problem with my code. Can I share the screen?
Yes.
Okay. Let's see. Now you can hear me better, or it's the same?
Louder.
Better.
Okay. Nice. Okay, I'm doing the third exercise with the potentiometer, and I don't know why this is an error. I don't know.
Let's see. Well, in the line number 12,
yep,
you are reading the value from the analog input, but the analog input.
Oh, it's not okay. Defined.
No.
Huh?
It's perfect. That's not the problem.
Okay.
The idea is that the analog read, you connect volts, but the value that you read is translated into a digital value that goes from 0 to 1023. Okay? So the idea is that in line number 13, where you have 1.25 volts,
yep,
the idea is that you do a translation into the equivalence, that is multiplied by 1023 divided by 5, but you can obtain that the value directly because it's 128 or something like that.
Well, that is still good. I mean, that is still well made. Just 1.25 multiplied 1023. That's it, isn't it?
No, and divide it by 5.
And okay.
But you will have a problem because there is something there in your code that we have not still explained, that here you have potentiometer, it's an integer value, okay? But on the right, you are doing a float value, 1.25 is a dot value.
Okay. Okay.
And you are
I see.
multiplying it by integers. It's well, we will see
Okay, so it's better if I put the
an integer.
the number. Okay. Okay. I
Yes.
see. Thank you.
But that's not the only problem. There are other problems. Okay, if you go
Okay.
now to number 20,
Yes.
lo de Y, I don't
Yeah.
know what is it.
I don't know. I just searched for it, and it was like, well, this is it. I don't know.
No, but I write it in my
It
document.
is okay.
You
Okay.
have it,
I'll
in my
I'll search for
document.
it.
In my document, you will have ampersand in at the end of page number 8.
Mhm.
You
Okay.
have
Yeah.
to read a
Yes.
little
It's
bit.
okay. It's here. It's here. I see. Okay. Thank you.
Okay. No one wants to show something?
We are working on it.
Okay. You are on the, more or less, all of you are on the third one, no? More or less.
Yes. Nacho, we have to close every if that we use in the code.
¿Cómo? What?
En español, tenemos que poner cerrar con el paréntesis de todos los ifs.
Well,
we don't need to.
When you write if, you must write the keys. But when there is only one instruction associated to the if, you don't need to use the case.
But if I use 3 ifs,
if you use 3 ifs, each time
I have to close each one, maybe?
Yes. Each one must be closed.
Okay, that's it.
Nacho, I have a question.
Please.
In example 5, are you there?
Yes.
Okay, why in the voice setup the code uses pin mode to input pull up? if there isn't any switch?
Because maybe I copied from a previous example.
Okay, but it's not necessary.
I am reading and I think not. No.
Okay, okay. Okay, thank you.
And do we need to change any parameter from the variable resistor?
What?
Do we
Change
need
it?
to modify the resistance of the potentiometer?
No, it doesn't matter because it's a resistive divider. So you have
Yes.
a fraction, no? You don't have to care about the absolute value.
Okay, so the voltage goes from 0 to 1023,
No,
right?
no. The voltage goes from 0 to 5 volts, but you have
Yes,
an
in the
analog to digital converter of 10 bits, so it goes from 0 to 1023 in digital values. In volts, from 0 to 5. No 1000 volts. 1000 volts, the microcontroller will burn.
yes, sure. Yes.
Okay, I have finished the third exercise. Can I show you?
If you want, yes, please.
Okay. That's right. Okay. I'm gonna start the simulation. Okay, so as I turn this up, the lights like,
Okay.
and that's it.
Molt bé. Okay.
Nacho, can I show the third exercise?
Yes.
You see that?
Okay.
And it's one.
It works, no?
Yeah.
Okay.
One question. If I in this line, well, I not try this, but if I write else in the last line,
No, it would be in a lot of time, in a lot of situations, because the else in line 38, sorry,
yeah,
in line 38 only affects to the
that
if in line 31.
okay. And
Another thing would have been to say
else if, no?
else if.
Yeah,
Yes.
I saw. Is that my other option?
Yes.
But I think that is the same that I write if and if.
Yes, because you are covering all the situations. Yes.
Yeah. But this else only affect that is if, no?
Yes.
Okay. Thanks.
Does anyone want to share or to ask something?
I have one problem now. I'm going to show it. It's not working.
Okay, please show to us.
I put it like with one if for bigger than this number, one between this and this, and
You are sharing the same resistor.
it's not a problem.
Well,
not
here
any
not,
time
because
work.
it's a simulator, but in the laboratory
It's
you will
because
have there some voltage. It's strange. I don't know what happens.
it's because
Okay.
the regleta today is not my friend.
What?
La regleta que hoy no me llevo muy bien con ella por lo del otro
Okay,
ejercicio.
okay. Okay. So, ask me
So
again,
I
please.
started and it gives me one mistake here, but it's literally copied from here. I only change it
Yes, go to your code. Go to your code. Okay, it's because void setup, you didn't close the key. In line number 9, you should, in line number 9, you should close. Okay.
return. It's the same.
That was the problem, I think. Is the thing that it said at the end, no?
Maybe. Okay, now is one working, and how when we change it? How does it work?
Please do something in void loop. In void loop, go to void loop, and between 12 and 13, write between 12 and 13, create a new line and write a delay. Well, be careful. 100. Parenthesis 100. Because we have no 100, no 1000, no 100.
Yes, sorry.
It's because we have seen before that if you don't put a delay, it's too fast and it gets crazy. So, dale a iniciar simulación. You need a semicolon. You need a semicolon in line 13. Punto y coma en la línea 13.
Yes, okay. Now I have this one. We change it. Now this one. And now is this. I don't know it. Maybe I didn't. Okay, I'm going to fix this. So I stop sharing.
Okay. We have only 3 minutes. So if you want to ask some question or to comment something, the idea is that the next day, we will start with the graph set. Okay. Today, the idea was that just in order to not to start with theory, that it's a little bit hard for the first day, I did this work to learn what is a microcontroller, and then the next day we will learn what is we will remember what is the graph set and how to implement it in a microcontroller. And the idea is that if we can, we go to the lab, and then we solve un montaje. We solve a real problem, okay? But I will think about that, because maybe we do it by simulation here in the computer as today, the same, no? I have to think about it, okay? Because la escuela told me not to go to the, well, like all your friends that are studying, no? They are forbidden to come to the university. So I have to study this idea to what to do, okay?
Okay.
Okay.
Well, Pues no res. ¿Cómo habéis visto lo que vamos a ver y todo eso? ¿Bien?
Bé,
Bien, bien.
Sí.
Ok. Bueno, pues para el próximo día, si esto lo queréis hacer, los otros ejercicios que hay y tal, la idea es que cuando los vayamos a necesitar ya concretamente, pues bueno, ahí están las líneas de código y ya lo abriremos y diremos, no, es esta línea de código la que leía tal cosa y ya está. Esto era un poco para que jugarais, ¿no? Para poneros a pensar un poco en código C, pues alguien se ha dado cuenta que si no pones el punto y coma la lías, que si pones una llave la tenéis que ir cerrando, cosas mínimas. Y mientras aparte habéis jugado, recordado pues, cómo se conecta una resistencia, la masa, tal. En fin, un poquito para quitarnos el miedo al cacharrín, ¿no? Al microcontrolador. Pero no le hemos metido chicha de control nuestra, de la asignatura. Eso lo haremos la semana que viene. Entonces, para la semana que viene, ¿qué podéis hacer? Bueno, pues podéis miraros esta práctica que la podéis hacer con el simulador en casa y acabarla por probar, por jugar. Y bueno, pues podéis desempolvar, aunque sea una lectura en diagonal de sistemas automáticos y de automatización industrial, a lo mejor no ya de los apuntes, de las transparencias, un poco de qué iba aquello, la nomenclatura, ¿no? Porque sistemas automáticos hace un año que hicisteis el examen y si lo aprobasteis, pues hace un año que no lo tocáis. Y automatización hará unos 8 meses, que si la aprobasteis, pues en mayo o junio que haríais el examen no lo habéis vuelto a tocar. Entonces, bueno, pues desempolvar un poco, aunque sean las transparencias y mirarlas en diagonal para la nomenclatura y tal que os suene, puede estar bien, ¿vale? Yo lo voy a recordar todo aquí, ¿eh? No voy a dar nada por sabido, pero, es decir, hay cosas que no entraré en detalle y diré, bueno, y esto se estudiaba con mayor profundidad en aquella asignatura. Eso sí que lo diré algunas veces. Por ejemplo, el diseño de los PIDs no vamos a volver a repetirlo. Lo haremos de otra manera, más a saco o lo que sea, para que no sea un requisito, digamos, lo que aprendisteis allí. Eso no quita la recomendación que os acabo de hacer, a poder ser, ¿vale?
Vale, perfecto.
¿Alguna duda,
Vale.
algún comentario o algo?
No, en principio no.
No.
Bueno, pues eso, os animo, ahora que no tenéis mucha faena, a poder jugar con esto y con la aplicación esa que os he dicho de aprender lenguajes, ¿eh? Que vayáis metiéndole ahí al
Sí.
autoaprendizaje que con esa aplicación la verdad es que está muy bien para aprender, no llegas hasta hacer la mano, haces proyectos ni nada. Son línea a línea de código, ir entendiéndolas. Y bueno, viene bien, ¿vale?
De acuerdo.
Vale.
Muy bien.
Bueno,
Vale.
chicos. Pues,
Vale. Chao,
Venga.
Nacho.
adiós,
De
adiós,
acuerdo.
Mucho.
Hasta luego.
Vale.
Se ve.
Dios.
Adiós.
Adiós.
Joder, qué rápido se va el colega.